So we did some of these exponential equations in class today, which is Monday. But for those that maybe missed or you need some more examples, here's some more solutions on how to solve these equations. So we'll look at number one here. It says solve each equation. 27 to the 2 minus 3b is equal to 81. My goal for these problems here is to try to get the same base on both sides. So we're thinking of numbers like 2, 3, 5, numbers like that to try to write 27 and 81 to be both the same number. So like 2 to some power or 3 to some power. Well, when I see 27, 81, I'm thinking probably our best case is number 3. If you're not very good with this, you probably need to get a calculator out. Okay, but I'm going to write both sides to be the base of 3. I can do that because 3 to the third power is 27. So I rewrote that to be 3 to the third power, and I'm going to leave the existing exponent that was there, that 2 minus 3b. I'm going to end up having to multiply that. So then on the other side, I got to think 3 to what power gets me 81? Well, 3 times 3 is 9, times 3 is 27, times 3 again, that's 81. 3 to the fourth is 81. I've got the same base on both sides. They're both with a base of 3. So if this, sorry, one second. If this right here is equal to that right there, and they have the same base, that one's a 3, and that one's a 3. If they have the same base on both sides, it has to be true that my exponents are equal to each other as well. If the two numbers are equal, then it has to be true that the exponents are equal as well. So with that, we can say, well, let's cancel both those sides out. Since they're both the same number, we can cancel. We're going to distribute there. We get 6 minus 9b equals 4. I'm going to then solve for b. So subtract 6, subtract 6. Negative 9b is equal to negative 2. Divide by negative 9. Divide by negative 9. B equals positive 2 ninths. Positive because I have negative over negative. B is equal to 2 ninths. So we looked at the original problem, tried to get the same base. We wrote them both as a base of 3, and we're able to solve. Looking at the next example, same idea, maybe a little bit harder, but not terrible. I've got 1 over 64 to a power and 8 to a power. Again, I'm thinking in my head, what can I write both sides to be? Can I write them as a base of 3? No. Base of 5? No. So then my next answer probably is, hey, it's probably a base of 2. So in my head, I'm thinking, I'm going from a fraction to a whole number. That means my exponent has to be a negative number. So 2 to the negative. Then I have to think, all right, 2 how many times gets me 64? If you play around with your calculator or you know it, it's going to be 6. 2 to the 6 gets me 64, and then I need the negative exponent there to flip it from 1 over 64 back to just 2. So it's negative 6, and then I've got the negative n minus 2 still left over. On the other side, I'm taking 8, and I have to write 8 as a base of 2. So 2 to what power gets me 8? It's 2 to the third, and then I've still got that 2n left over. Again here, I've got a base of 2 on both sides, and they're equal to each other. That means my exponents have to be equal. So I can basically say I can cancel those out, and I can just worry about the exponents. That'll be 6n plus 12 is equal to 6n. I subtract 6n, subtract 6n, 12 is equal to nothing. That's not the right answer. That is a no solution problem. Okay, anytime you get your variable to cancel away there, you're going to get no solution. 12 doesn't equal to 0. That doesn't make any sense. But again, answer might be somewhat strange. Our goal was to get the base equal to the same thing. 1 over 64 became 2. Negative exponent because we went from a fraction to a whole number. On the other side, we took 8 to become 2 to the third power. If you have any other questions, please write on my wall. Please send me a question on My Big Campus, and I will get it solved for you. Hopefully that helped you out.